So the motivation for Swirl, this Swirl started in the summer of last year, 2013. And it came out of a conversation that I was having with Brian Caffo about the lack of existing resources for learning statistics in R interactively. Obviously, the market is flooded with textbooks, websites dedicated to teaching people how to use R, how to do basic statistics. But quite frankly, I was jealous. I was actually trying to learn R and statistics myself. I had been out of school for 4 years, so it was a steep learning curve for me. So I was a little bit jealous of like people who were learning Python and JavaScript and all these other more mainstream computing languages, because they had things like Code Academy and Code School and Treehouse, which is, if any of you have seen these things, they're really great websites for learning the basics of programming in various languages. We'd have nothing like that. So we're kind of like, R is kind of like a rogue language to begin with. It belongs to statisticians. It was created by statisticians. People who use it are mainly statisticians or people from other fields needing to do statistics. But it is a full-fledged programming language and should be treated as such. And hopefully what we've created here is a tribute to that, because we've done it all in R. So I think I pretty much covered everything here. I guess this is actually, the first bullet point is kind of the most important. It's like, well, I talked to a lot of people who, particularly non-statisticians, who are taking statistics courses here at the school, and they take a class and the teacher tells them they have to learn R. And so they're used to using things maybe like Stata or SAS that are generally point and click. They have a nice graphical user interface, pretty user-friendly. And then all of a sudden the teacher says, now you got to learn R. And they show them this command prompt. And they're like, what the hell is this? What do I do? And it's very, very intimidating for people who have no programming experience and no prior experience using R. So Swirl is an attempt to make that a little bit less intimidating. Some of you know some of these things. I'm going to cover them all over the course of this presentation. But basically, Swirl it turns the R console into an interactive learning environment. So you all spend lots of time in the R console on a daily basis. It basically creates a dialogue between you, the user, and Swirl, which is a combination of things working in the background. But it's some content that somebody's written, some instructional content, along with the platform, which is responsible for delivering it in a way that's interactive and hopefully engaging. So the important thing about Swirl is it teaches statistics and R simultaneously. So this is a fairly novel thing. There are a couple people who have attempted something similar, but for the most part, we're really the only people doing this. A lot of people are trying to teach R interactively, but most people don't want to touch statistics with a 10-foot pole because, let's face it, it's hard to learn and it's even harder to teach. So Swirl is interactive, again, continuous dialogue. The user is getting immediate feedback, which I think is a critical aspect to learning anything new. We've all taken classes where we submitted homework after homework and essentially had no reason to believe that the professor had even ever gotten the submission. There's no feedback mechanism, and therefore we have no way of correcting ourselves for doing things wrong. Very, very deeply ingrained in Swirl is this idea that in order to learn something effectively, you need feedback. It's authentic. It's actually as authentic as you could possibly get. This is one of our claims to fame, because Swirl, for any of you who have actually used it, it's not pretty, right? It's like you're in the R console. We're working on ways to make it prettier, so it's getting more interesting in that way. But for the most part, you know, people are used to like these flashy websites using fancy JavaScript and things are moving around the page and colorful and all this stuff, and then they see Swirl and they're like, "This is I feel like I'm going back in time a little bit." But that's the point, because there's no separation between the environment that you're learning in and the environment that you're actually doing data analysis in once you're done with Swirl. You are on the R prompt, interacting with the R interpreter, except with Swirl you've got a helping hand. we're open source. So we're on CRAN, as I mentioned, and we're also on GitHub. For any of you who are not familiar with GitHub, we should talk, because it's like in my opinion, one of the most important things to happen to the internet and the scientific community ever. So it is a very large statement, but I think you hear a lot of people running around talking about reproducibility, and that's really at the core of GitHub. And so for those of you who have not used it, it's essentially a place for you to host your source code for a project. And it's particularly helpful if you're collaborating with other people, because it allows you to interact with people and have a discussion about changes that are being made by multiple parties. It's called a version control system. It's based on Git, which is a version control system that allows you to kind of take snapshots of a project over time. And if you're working, if two people are working on the same aspect of a project, and then they both try to submit a change, and there's some conflicts there, if you've made different changes to the same part of the project, GitHub is really designed to help you resolve those conflicts in an orderly fashion, have a conversation about it. So anyways, that's enough of a sales pitch for GitHub. Finally, it's extensible. So what this means is that R was designed as a language for interactive data analysis, but it actually has several what are called object-oriented programming systems built into it. So for many people, this is a source of frustration, because typically there's one system for doing object-oriented programming in a language. R's got 3 of them. But if you learn how to use them, you can actually do some real programming. And that's been able to help us considerably. And one of the nice things about it is it also facilitates the ability to add on to the original project very simply. And if you're interested in adding on to the project, you can talk to me about that. So what are the uses of swirl? I don't know. There's a couple that are immediately obvious, and there's others that have been presented to me that were not immediately obvious but are great ideas. So the most obvious reason to use swirl is to teach and learn statistics and R interactively. But another fantastic application of swirl that actually Leo brought up to me, I think actually various people have mentioned it to me over time, but I give Leo some credit for that, is so you all are aware when somebody releases an R package, it's customary to create a vignette that is generally a PDF document or an HTML file that walks somebody through a use case of that package, typically a data analysis because it's R. And so one great use of swirl rather, which it really plays perfectly into what swirl does best, is to create an interactive vignette where you walk somebody through a data analysis interactively in the R console using a new package. And this is very easy and very natural to do, and I'm actually hoping that this kind of catches on with people, because I think for package authors it could be a huge draw. So domain-specific applications. So the original audience for swirl was beginners, people who are terrified by the idea of a command prompt. But as swirl develops, we'd like to have more and more advanced content, and there's no reason we can't do this. So actually Jeff right now has assigned as his class's final project, many of you are aware, everyone in his class has to write a swirl course that walks people through an advanced topic in statistics. And so this is pretty cool, it's pretty exciting for me, but let's say you work in neuroimaging. It's obviously a fairly a niche topic, but there are some important applications of statistics and computing in this field. Let's say you want to create a lesson that teaches people how to do statistics in the field of neuroimaging. Swirl is a good platform for doing that. Another thing that I just thought of kind of while I was putting this presentation together is for replicating data analyses. So if you can do a data analysis in R, then you should be able to walk somebody else through that exact same data analysis in an interactive fashion. I've never actually tried this, but I mean, this is essentially what we're doing in, let's say, a lesson that's teaching people how to do t-tests in R. Except in this case, we'd just be using a specific data set and probably a broader range of analyses. What else? I don't know. You guys tell me. So honestly, some of the best ideas from Swirl have not come from my brain. They've come from other people. So if you have some ideas for how you could use it, I'm all ears. Okay, so how does it work? Clearly that's not that's not really true. So how does it really work? Does everybody know who Hadley Wickham is? If you do, you're a huge nerd. I know who Hadley Wickham is.
You guys are best friends.
Yeah. I seem to think so. I don't know if you'd agree with that. So Hadley Wickham is probably the most prolific author of R packages, particularly in the last I don't know, decade or so. He's the chief scientist at RStudio. Many of you probably know what RStudio is. But essentially, he just writes packages that people tend to find extremely useful. He's also very serious about treating R as a programming language. In fact, he's been authoring a book called, I think he's changed the title a couple times, so it's something along the lines of Advanced R Programming. If you Google that, it'll be the first thing that comes up, his book. It's all freely available to anybody. And actually, he, I believe, wrote it using GitHub pages. Anyways, I've kind of been in touch with him since we started this project. He's been grateful enough to impart his opinion occasionally, and so he presented us with. After I released the first edition of Swirl, which was pretty. It was functional, but it was pretty messy. He had suggested we use this thing called a callback mechanism. So this is kind of a technical detail of Swirl that I'll just touch on a little bit because I think it's an interesting use of some of the built-in technology in R. But there's this function in R called add task callback. And essentially what this does is it creates a little listener that works in the background where it captures anything that happens at the R prompt. And so it'll capture, let's say I type x gets the value 3. It'll capture the expression x gets the value 3. And it'll also capture the value of that expression, which in this case would be 3. And so if you're clever, you can actually tap into that and you can intercept that information then. And then you can choose to do something with it. And so that's essentially at the core of Swirl. There's a lot more stuff that is built around that over time, but that's the main technology that has really made Swirl feasible.
So you didn't have that?
We didn't have that. So there's a function called readline,
yeah.
which essentially just lets you get a string input from the user. But getting a string input from the user is very, very different than getting an R expression from the user. An R expression is like an R language object. So R, the way R works, or any programming language works, is it gets some input from the user, and then it parses it. Basically, R's got like this built-in dictionary that says, okay, this symbol means this symbol means that, this symbol means that. And so we're essentially tapping into that. So instead of getting a string from the user that looks like an expression and then trying to figure out what does it mean, we actually get the actual expression from the user and allow R to tell us what it means. And then we just pick it apart and pay attention to the elements that are interesting for our purposes. And then so you can kind of think of it like we're listening for certain conditions to be satisfied at the R prompt because of this callback mechanism. But then what makes Swirl Swirl is we kind of wait for certain conditions to be satisfied. So maybe we're expecting the user to create a new variable that stores the value 3. Well, that would be specified somewhere. But then when the user can enter a bunch of things at the R prompt, but then when that condition is satisfied, there's some feedback provided, and the lesson proceeds. It moves forward. Does that make sense? So those conditions that I'm talking about, those are specified in the content, which is separate from the platform. It's separate from the code. There's content that's stored externally to the swirls, to the source code for swirl. That content's read in, but then it essentially sets up a series of conditions that need to be satisfied as a user works through a lesson. So I'm talking about swirl in a very abstract sense right now, but it'll become a little more concrete. So this is kind of a diagram representation of what's happening. I'll just sort of walk you through this. Depending on what you guys are interested in, I can spend more time on certain things. I'm always happy to talk afterwards, but I don't want you guys to start falling asleep. But basically, the user enters some expression at the R prompt, and they hit return. So this is the R prompt. They hit return. The expression 5 plus 7 and the value of that expression get sent, get kind of like picked up by this callback mechanism. We store that information in a special environment, and we call that environment E. And the reason we do that is because while so let's say they were saying X gets 5 plus 7. That'll show up in the user's workspace, right? They'll see there's been a new variable called X is created in their workspace, and it stores the value 12. But we also want to kind of peel that off and use it for our own purposes behind the scene. So we kind of like hide a bunch of stuff in a separate environment. So the stuff that shows up in your workspace is called the global environment. We have our own little environment that's operating in the background where we keep all of the stuff that we need to keep swirl operating correctly. And the user does not see any of that. So it keeps their workspace pristine, which is important. So then we pass that to E. We stash it away in E. And then we pass E to swirl's internals. And that's where all the magic happens, where basically based on the instructions laid out in the content that some content author has created, the instructor's created, we do something with what the user entered. And then we do something, and then we basically go back to the R prompt. And so it's just this continual cycle. Again, talking about swirl in sort of abstract terms, I think as we go forward, it's going to get a little more concrete. Any questions so far? All right. So again, more technical details, but this is essentially the core of swirl. It's actually extremely fascinating if you're a really big nerd. It's really, really cool because we basically took this idea of what we wanted swirl to be and we abstracted it as much as possible. And this is what we came up with. And so everything that makes swirl special was built around this very simple idea. And so just very quickly, if you start swirl, the way that you do it is you load the package and then you type swirl, which swirl is a function. And what it does is just ignore that first line. That just basically makes sure that we don't have another swirl running already when we start it. So that just gets rid of any existing callback that's operating in the background. This sets up our clean environment, right? This is like our administrative environment, E. Callback is the callback function. So actually, let me come back to that. So I define this function. We'll just call it the callback function for right now. And we come down here and we add the task callback. So this is what adds the listener. And what I do is when I add the task callback, I specify this callback function, CB. And what this does is it says, when the user enters an expression of the R prompt, pass some information to the callback function. Right? So that's where we come back up here. So let's say I enter X gets 5 plus 7 at the prompt. The callback then will pass some information to the callback function. And what it passes is the expression, which is X gets 5 plus 7, the value, which is 12, OK, which is actually, it's always true. It's a feature that has not even been implemented yet. And visible means whether the result was printed to the R console. Anyways, it's not really important. And then data equals E, which means we're passing that special environment to the callback function. And then what we do is we take these things, we take the expression, and we assign it to our special administrative environment. So we're capturing it. And then we do the same thing with the value. So now the user's entered x gets 5 plus 7 at the prompt, and we took that information, and now we get to do whatever we want with it because it's in E. It's in our administrative environment, and it gets past the swirl's internals, and that's where the magic happens. That's the gist of it, without going into too much boring details. Yes? Charlie?
So like every time you run this function swirl, and after that you just go back to your console and type anything, and as soon as you type anything, it will be called by your callback function.
Correct. So the callback mechanism, anytime there's what's called a top level task, which essentially means somebody enters something at the R prompt. The callback captures that information I just told you about, and it passes it to whatever callback function we specify. So this is what we did for swirl, but you could set up a simple case where you kind of like set up a counter, and I initiate the counter. I type something at the R prompt, and it says, and then it prints the result as it normally would, but then it says 1. And then the user types something else at the prompt, and then the counter increments, and then it prints 2. You could do something like that's not very useful. You could also set up something where every time that the user types something in the prompt, it automatically saves your workspace, or automatically saves your some document that you have open. So that would be a more practical use where you're kind of like creating a backup mechanism as you're going through a data analysis, something like that. But this is a very, as far as I know, this is a very obscure function in R. I don't really know anybody who uses this. Thank goodness for Hadley Wickham, because we would have never found this thing. So, Aaron, you have a question?
Are you storing just like one expression at a time, or?
Good question. So we keep a running list. So each time the user enters something at the R prompt, we capture it, and it gets sent to E. But then behind the scenes, we're stashing that information, and then we just append to a list, essentially, as the user goes through the lesson. So we have a full history of what the user has entered at the R prompt as they've gone through a lesson. And this is the basic idea behind how we save progress. There's some tricky details of that because, like, let's say the user enters something bogus at the R prompt that didn't answer the question correctly, and like, we don't want to reproduce that if the user stops the session and then restarts later. So we actually restore progress by only restoring the things that answered questions correctly. So there's lots of like little details like this that needed to be thought out. But the essential idea is we keep a running tally of what the user's done. They stop, they go do something else, and then they come back to swirl and it restores their progress. That's the idea. Any other questions so far? Cool. So really the most important thing the most important thing right now is content. Jeff always tells me content is king. So we can build a great platform, but if there's crappy content or no content at all, who cares? Because it's not effective for instructors, it's not effective for learners, it's not effective for anybody. So we've got some core content that I and some other people have written over the last 12 months or so. And some of it's better than other stuff, but we're getting better. But we're kind of in the process where we're trying to focus more attention on making the process of authoring content more enjoyable, because we want to make it as easy as possible for the people with the know-how to transmit that information to the people who want that know-how. So basically right now you can author content in a variety of formats. This has actually changed over time. So we started off with authoring content only in CSV files. If anybody's ever worked with CSV files in Excel, you might understand how frustrating that can be. Try authoring like content in it, and you want to blow your brains out. So,
Yeah, what do you mean by content? Do you mean like
sorry,
questions? And
good idea. I'm sorry, good question. So, when I talk about content, I mean think of like a textbook, the words on the page. So there's some output to the user that says, today we're going to teach you how to use the t-test function in R. Then maybe you present the user with a question. What's the name of the function that you use to do t-test in R, and you give them a series of options and they select one. Or you do a command question which says, okay, now do a t-test on the data set called this, and they actually enter an expression at the R prompt, and then if they get it correct, there may it goes on to the next thing. If not, there might be some hint. So this is all words that somebody had to write down.
Right. Seems weird to write that in CSV.
I'll tell you why we did it, because it's a structured
Right.
data type, right? So one thing about this is we need to structure the data somehow, and because the lessons happen in a linear fashion, you start at the beginning and you work through to the end. You need the main output to the user, the words on the page that they see, but you also need to specify, attached to this question, what's the hint if they get it wrong? What's the expected answer, right? So the natural inclination is to use a table format, because you can have the main output on the left-hand column and then kind of the metadata that's attached to that as you go to the right. It makes sense intuitively, but from an author's perspective, it's a nightmare. So we've kind of iterated over time. Now we can author content in R Markdown. The trouble with R Markdown, the benefit to R Markdown is it's a familiar format for people. It's a natural format because you're authoring content in a vertical fashion, right? People are used to typing words on a page in a vertical fashion, not type. You wouldn't type a book in a table. You'd cry. The trouble with it is there's this trade-off, right? Because you get to author in a more natural format, but it's much less structured. The data in an RMD file is much less structured, so it forces you to use all these annoying tags to say, hey, this little blurb is the hint, this little blurb is the question, this little blurb is the answer choices. You have to tag all these things, which means you have to remember the names of the tags of all these things. So it's better in some cases, but it's not great. So I'm going to talk about this a little bit more, but I think the next step for us is we're trying to create what's called a GUI, a graphical user interface, but basically a web form, a form that people can fill out that adapts based on what they're trying to create. So if they're trying to create a command question, and we know there's certain things that we need to know in order for a command question to work, then it'll only present them with little text boxes for those things. And then they hit submit. It'll auto-populate the content for them.
So I was wondering, have you guys considered maybe like XML? Because it seems like that's kind of like, what?
Or JSON.
Yeah.
Actually, we're
that's-
using YAML now. So
Yeah.
so YAML and JSON are very similar. They use key value pairs.
Yeah.
Honestly, the reason yes, I've thought about these things. The reason we use YAML, or we're leaning towards YAML now, is because it's very structured, but it's in a vertical format, so it's a natural top-to-bottom format. For those of you who don't know what YAML is, I'll actually show you an example. But it's basically title equals intro to R. Author equals Nicholas Carcetti. It's key value pairs separated by colons. And then that's the gist of it. The reason we kind of prefer that is because, well, first of all, it's very human readable, which is important. We want people to be able to look at a content document and very easily see the important aspects of it. JSON, I think, adds a little bit more complexity to the page. It's probably a little bit more structured. YAML relies on white space to kind of separate ideas. But because of that, it's very readable. I was going somewhere with that, but it's gone.
That makes sense. I mean,
Yeah.
YAML seems like a good choice.
It's kind of there's a trade-off. YAML seems like a good place to be, but I think what we can do is that can be kind of working in the background, that or maybe a JSON file eventually. Oh, the other thing is it's very it's trackable on GitHub, which is really important to us. So GitHub, or Git, I should say rather, tracks text documents very well. So you can, if I make a change in a text document, we'll see that change exactly, and I can very easily see that. So it's very transparent. Anyways, let's get to the more interesting stuff. But the one point I just wanted to make here is, so we're trying to make this as easy as possible for the content author, which eventually means, I think, creating a form so that they don't have to memorize all these tags. They just fill out a form and hit submit. That's the idea. But then in the background, it would be populating a more structured data type. Yes?
You can do that already with Excel. Like creating forms in Excel is
So, yes, we're trying to integrate everything very cleanly. So we want it to be like, so what I've done is, I'll show you a screenshot in a second, but I've created a Shiny app that runs in the viewer pane in RStudio, which is very, very cool. So you can have the document that you're authoring up on the left-hand side, and a little Shiny, it's a web application basically that you can write that is running right in RStudio. So you see the web form here, you fill out the form, you say I want a command question, you fill out the form, you hit add, and it appends it to your text document right over here, which might be a YAML document. So we've got this prototyped already, but it's just not prime time yet. But I think it'll be a significant improvement for people. And then you can go back and always edit the YAML document if you want to. But this will I think, ease that initial burden of creating the structure that we're looking for. Right now, if you want to write content, R Markdown's the way to go. We've got a boatload of documentation on the website, which I'll show you at the end. Yes?
I know this is really up to handy, but it seems like it would be really cool if we integrate this into RStudio.
If we could get into RStudio?
No, if you could like not integrate it with RStudio.
Yes.
Yeah.
Oh, that's the plan.
Yeah.
Hadley doesn't know that, but that's the plan. Yeah, I mean, I'm in touch with him on a fairly regular basis, and I'm constantly looking for ways that we can integrate more thoroughly with RStudio, because quite frankly, I think that RStudio is driving the future direction of the R language.
That also take care of your make it pretty.
Yes, exactly, right. So there are many reasons why integrating with RStudio is probably a good idea, but we got to build it first so that we have something, we got to
Leverage.
Right, they're busy enough as it is. Like, we can't say, hey, can you guys build this for us? So we'll build it, and then we'll say, hey, do you want this? That's the plan. So I'm actually recording this presentation, so maybe Hadley will see this at some point and maybe get really mad at me or something. All right, so authoring content. At this point, like I said, our Markdown's kind of the way to go because we have a ton of documentation. It's fairly easy to do. And you can just basically type this function, author lesson, give it the name of the lesson, give it the name of the course, and it'll automatically bring up a customized R Markdown template that you then just replace the text with the text of your own. We use this really cool package called Whisker, which is a wrapper around something called Mustache. And what Mustache does is it basically you have like a text document and you put these little placeholders in the text document, and then you pass some variables to a Whisker function, and it substitutes the placeholders with the variables you give it. So like the user specifies the lesson and course name, so we have little placeholders for the lesson name and course name in the course document, and it automatically populates that. So this is the kind of stuff you find this on GitHub, right? This is not on CRAN. But if you learn your way around GitHub, you find these crazy cool things that other people have written. So that's what it would look like. This thing would pop up. It would actually be opened for you, and then it's you see it's pre-populated with this information. This is YAML. So we use YAML at the top of the document to specify metadata about the lesson, and then the actual lesson itself is a little more freeform. That's our special flavor of R Markdown. But this is just like the default text that you can then replace with your own and make a course. And some of you are doing this right now, so hopefully you find that easy. Okay, so we go till what? A 1:15?
Yeah.
Okay. What slide number are we on? I don't know. All right, I want to make sure we got through everything. I kind of given this idea, but like there's different, we call them units of content. So you can kind of think of a course as being made up of lessons. Each lesson generally covers maybe 1 or 2 topics. So just like a course here at Hopkins, you have a course, say causal inference, and then you cover instrumental variables in one lesson, you cover, etc. Swirl is organized in that same general format, but then a lesson in turn is composed of what we call units of content. So a unit of content is like 1 paragraph output to the user, text output. Then you have a question, maybe. A question can be a command type question that asks them to enter an expression at the R prompt. It could be a multiple choice question. It could be text based. They enter a word at the R prompt. Technically, it's not actually at the R prompt because R's interpreter wouldn't know what to do with it. So we have to deal with different questions in different ways. That's beyond the scope of this conversation. And finally, we could say like we could show them a plot and be like, what based on this plot, what do you estimate is the mean? And they could like input a number like 20. We can also prompt them to watch videos. So we can be like, we just taught them a bunch of stuff. Do you want to watch a video created by Jeff Leake on how to do t-tests? And if they say yes, it automatically opens their browser and navigates to say like the YouTube video or whatever. We can display plots, so that's kind of cool. The plots that we have in our content right now are very simple, but you can imagine in the future we'll create plots that maybe run in a Shiny app that are interactive, use JavaScript libraries. So we can do pretty cool stuff with that. And then actually in development at the request of a student who is not here right now, I believe. Oh, sorry, I didn't see it right up front. We are actually, you had requested that we be able to display math notation. This is a tricky thing for us because we're operating in the R console. You can't display anything that's marked up in any sort of interesting way in the R console.
Do you mean like what? What do you mean like alpha?
How do you show an integral sign in the R console?
Unicode.
So like,
You're telling me that you can show.
Yeah.
There is an actual symbol that represents the integral. It's a small one. It's at the same level of everything.
Okay, that sounds horrible. I mean, it's a great idea. I didn't know that, but it sounds like it's not very readable.
It's not going to be as readable as we.
You can't do like fractions and superscripts and stuff.
Right, like could I write the equation for linear regression? Could I use beta with subscripts and?
You could theoretically do it through plot math.
Okay, right. You can.
Is that a clause?
Let me get to what I think is probably a good solution for this.
They're already assuming that they already have a plot. I mean, they're already doing plots in RStudio, so what's
You can
the
do a
big
lot.
test?
It's limited.
So I think the best solution would actually use like a MathJax library, which is essentially a web version of LaTeX. But the question is, where do you display it? Thanks to RStudio, there is this thing called the viewer pane now, which is capable of displaying web documents, HTML, JavaScript, CSS, etc. And that's what we're going to be using for this this course authoring GUI. But I also have a prototype thing that is capable of displaying math notation. I think I include screenshots at the end of this, so you'll see what I'm working on. But I think it's pretty cool. So in terms of sharing content, so you create a lesson. Now, how do other people access that lesson? The answer is pretty much any way possible. So you can put your course on Dropbox. You can put it on Google Drive. You can put it on GitHub. You can host it on your own personal website. You can send it in an email. Doesn't matter. Whatever you want to do, we've got a function in Swirl that allows a student to install from wherever that course is located directly. So they're at the R prompt, they type install course GitHub, they type the URL for the GitHub, for the directory in the GitHub page, hit enter, and installs the course. They enter Swirl and it's in the menu. So it's very, very easy to share content once it's created.
Would you be able to have, let's say,
That
Google Drive?
that next slide is going to require some explanation. Go ahead.
Okay. Yeah, the if you don't have to share with everybody, only the people in the course.
Yeah, so you can share it privately with just one person, or you could, if you wanted to, we would work with you to actually incorporate it in a more central location, maybe as part of the package itself that people get with the core distribution of Swirl, or we're in the process of creating like a course repository where we keep like auxiliary content, and then people just type one line, install from Swirl, give it the name of the course, and it pulls it down and installs it. So ultimately, we want to have like a marketplace of courses where people can create. If you're interested in machine learning, you go to the machine learning section, and there's like 50 courses on how to do machine learning in R. These types of things.
But where you guys get like a password option?
Yeah.
Like
You're saying, can you explicitly make it private?
Yes.
Anything that you put on GitHub is public, unless it's a private repository. If it's a private repository, okay, let me abstract the question a little bit. Someone would only be able to install the course if they knew what the URL for the course was. So that's fairly private. Now, could you create a course?
You could create a tarball, right, that you release on your website, right? Just the binary on your website.
Yeah.
I mean, they could share that, but that would be an easy way where you just create a thing, they install it, right? Where they don't go through GitHub.
Yeah. So you could, on your personal website, you could just put a file,
Yeah.
host a file on your personal website, and I mean, it would be pretty. Unless somebody told somebody else about it, nobody would know it was there. If there's like sensitive information there that actually needs to be like password protected, then the answer to your question is no. There's no way for it. We could figure it out, I'm sure, because like there.
You would have to just you have an option, a function to install source, right?
What's that?
I mean, you could just send it by email. Kind of thing.
Yeah. You could just send them the file. Yeah, but we don't have a way to. Yeah, there's no password protection or anything like that. But we could do that. There's ways. There's precedent for that. But yeah.
So I guess in the grand scheme of things, I think this is very nice. But the question is, does it help people learn R better than whatever's out there? And I think it probably does. But
Yeah.
what's the plan for like actually seeing that?
Sure. So we're working on tracking user progress and actually retaining that. We would have to ask for explicit permission to actually access it. But at least the first step is to track it and store it somewhere on the user's computer, and then give them the option to share it with us for whatever research purposes. Based on anecdotal evidence, people seem to like it. We get a lot of feedback from people who have been terrified to start learning R, used Swirl, and had a good experience with it. We're statisticians. We don't rely on anecdotal evidence, but I think when you don't have a better way of learning about something, that's a good start. So it's in the works. We're not there yet. Eventually, we want to have a dashboard for instructors where they can actually compile information from all of their students in a single view and keep tabs on, hey, how's everybody doing? The whole point of Swirl is we're working towards mastery of a topic. Self-paced learning, right? You don't move on until you understand the requisite stuff. And so, it's all in the works. All right, this requires some explanation. I did not create this. My helper Bill created this. Apparently, there's this like brony subculture. It's grown adults, particularly grown men, I think, who are fascinated with the cartoon My Little Pony. So if any of you are bronies, you might like this slide. But this is just an illustration of some of the places you can get Swirl courses. Moving on. All right. Answer testing. Okay, I want to make sure we get through everything. Answer testing in itself is like a field that you could spend an entire career working on. So basically the core question is, given some input from the user, how do you decide if they have completed the desired task? There are so many different ways that you can do that. And there is really no, as far as I'm concerned, best practices way of doing this yet. The way that we do it is we capture the expression, and then we ask, essentially, in the content, we ask if certain conditions have been satisfied. So we wrote some functions that an instructor can specify, like that basically say, did the user create a variable called x? Is the value of the R expression 5? Is the class of the expression a character? All of these different things. And so we have this library of answer tests that an instructor can specify to try to figure out if the user got it right. If all of those tests pass, then the user advances. If one or all of those tests fail, then they get a hint and they repeat the question. That's the main idea. We're trying to, this is again active development. We're trying to figure out, we're trying to build a better mousetrap. So it's a very interesting area. There's some things out there that sort of set a precedent for this with like the Hadley-Wickham's, of course, package called TestThat. TestThat is a package for unit testing, essentially unit testing functions. So what you do is you feed a function some input, and then you say, I expect that the output will be this. If it matches, and that's true, then the test passes. If it doesn't match the expected output, the test fails. It's a similar idea, so we borrowed some ideas from him. But this is a field unto itself. And lots of big-name people are working on this stuff, like Coursera. Maybe you guys have heard of Coursera. Right? These are the types of problems that Coursera is trying to figure out. They're Coursera. We're just a couple of guys. It was too much free time on our hands.
If you're keeping track of user data,
yeah.
are you able to keep track of all their answers? So if there's a question that people answer wrong the same way, or if there's an alternative answer that they contemplated you think of, you can keep track of that.
So there's exactly. So there, you get to a good point. There's many reasons we might want to track user progress. One reason would be to evaluate students, figure out if they're learning. Another reason is to figure out if we're doing something wrong. If everyone's failing on the same question for the same reason, it's probably not their fault. That's probably our fault. It would be great if we could learn from that. Right now, we're not. We have to rely on people telling us. Fortunately, there's something called GitHub, which allows that conversation to happen very easily. People submit issues on GitHub, on our GitHub page, and then we can systematically deal with those issues. Leo is a very, he's a prolific issue writer, which is fantastic. If you have questions about creating an issue on our GitHub page, see Leo. All right, so anyways, this just shows you kind of how you would specify these. So var, we try to do it in a natural language way. So this is a function. Var is a, ignore the syntax highlighting. That's a product of the markdown highlighted in our studio. But we say like var is a character. My name. So my name is the name of the variable. We're checking, is it a character? If it is, then this test passes. It returns true. If it doesn't, it's false. Expression uses function. C. Did the user use the C function in the expression that they entered the R prompt? Right? So you give it a battery of tests. If they all pass, we think that the user did the right thing. That takes some work, though, on the instructor's part. Right? It takes some thought. We also have kind of these catch-all tests. We call it omni-test. I think the name came from like Omnibar, which is the little bar at the top of Google Chrome, which is like you could type a URL in, but it's also like searches the web for you. They call it the Omnibar. So this is our Omni test. It's a catch-all. So it basically says, does the expression match what we consider to be like the correct expression, and does the value match what we consider to be the correct value? That's the main idea. It's a simplified answer test. But there's no leeway for the user. When they do that, there's only one correct answer. When you do it this way, you might be able to solve the problem in multiple ways as long as you pass these tests. Okay, let me keep moving. This is a list of the answer tests. One very neat feature that I have to attribute to my lead engineer, Bill, is that you can write a custom test in a folder. So this is something Jack is dealing with right now, but you can actually write your own tests, and if you put them in the right file in the right place, Swirl actually grabs those, places them in a special environment, And it's as if the functions that you write, the tests that you write, show up right alongside the ones that we've written. So it basically appends your tests to the existing tests. It's a very neat feature. And you can imagine there would be situations that our kind of like default tests might not address. There can be some funny things happening when you get into like random numbers or plotting. How do you test plotting? Right? Do you want to test it pixel by pixel to see if they got the right output? Right? There's things that you could do that currently we're not doing. So what's next? Course authoring is a number one priority for us. There's some special things that we're working on that I maybe will not disclose quite yet because we're not there yet. But it will be pretty awesome when we get it to work, and you'll hear about it, I'm sure. So that's like our clandestine operations. But in terms of stuff that we're transparent about, there's a course authoring GUI that's in the works, hopefully making course authoring more pleasurable for everybody. Functions to publish courses. So right now you can manually put your course on a Dropbox account or a GitHub account, and then somebody can grab it off of there. We'd actually like to have some functions that allow you to publish, to automate the publishing process, essentially, like that it puts it in your Dropbox account for you. Some things we can do, some things we can't do. Leo has some opinions on this. I'm going after Leo here, but honestly, some of the best ideas we've had have come from him, so it's completely joking. It would also be great if we had a central course repository. Somebody could write a lesson and be like, publish, and it shows up in our course repository for anybody to download anywhere. So we've got ideas on this. Again, central repository for swirl courses is something we're thinking about. Displaying math notation, it's in the works. I really hope I have a picture. I think I have a screenshot coming up, what that looks like. And then creating like these more interactive web-based applications that show up in the viewer where people can interact with a plot and then move a sliding bar, and then when it's in the correct place, they hit a button and it returns the value, so then we see if they got it right that way. So just different ways to test people's understanding. Okay, so this is a screenshot of like it's kind of hard to see, but like this is the course authoring GUI. So it's pretty neat, right? Like I've got a web application running in RStudio. It's served locally, which means that it's not a website on the internet. This is running on my computer. So I say, okay, I want to create a command question. This is a little drop-down menu. And then the form dynamically updates, and it gives me the fields that I need to complete. Nothing more, nothing less. It comes with some pre-filled information. I click, that disappears. I give it some information. When I'm done, I say add it, and then it appends it to my document. I think it's pretty awesome. And I think it makes it a lot easier to author content, and you can just forget about memorizing all of these special tags that essentially they have no, it's just a middleman. It would be great if we could eliminate that from the process altogether. So I'm excited to deploy this. It's not ready for prime time yet. If any of you know ShinyWell or JavaScript, come talk to me, John. Displaying math notation. I'm also completely excited about this. So this is a lesson that I'm running right now. It's very hard to see, but I select my course. It's this. This is a little test course that I wrote, exploring math notation. Okay, in this lesson, we'll explore an experimental feature that allows you to display math notation. It brings up. This comes up automatically. Okay, that's pretty nice looking. It's no Unicode or whatever, but
It's
right?
much better. Yes.
Pretty sweet looking, right? You can do anything in there that you can do in LaTeX or Markdown. Hit continue when you're done, and it returns you to the R prompt. All right, that's what I'm talking about. So that I threw together earlier this week. I'm pretty excited about it. That's also not ready for prime time, but
So why don't you run all things in the viewer?
good question. In the future, we might. It's possible. Then we'd look a little bit more like Code Academy, right?
Yeah.
The question is, do we want to look more like Code Academy? They've clearly been successful. But I think one thing that adds to the appeal of Swirl is this kind of like, maybe I'm going to use the wrong words here, but like, it's kind of got like a romantic, like intimate appeal where you're actually engaged in this continuous dialogue with the user. And like it's not this like you're moving like from discrete exercise to exercise, and each one is like a new window. It's a dialogue, and so it kind of in a way like imitates a data analysis. When you're working through a data analysis, like you're working down the page. You try something, it doesn't work, you try it again, but it's not like you have a new screen every time that happens. So I think for now we kind of want to stick to this. We kind of like that aspect of it, and it makes us frankly unique, which is pretty hard to be these days. John?
Does like a whole course or a session, does that create like an R script for you with all the commands that you ran successfully?
What do you mean?
So like you go through
Yeah.
cars, MIME, EG, all that kind of stuff. And you do all the assignments and all the box plots and stuff.
Mhm.
Now, let's say I didn't want to go through Swirl. I said like that was my analysis. I want to run that.
Right.
Is it like can it pop out a script? Because that's the whole thing. Is like this is good for interactive
Sure.
stuff. That the next step is for getting users to work in scripts.
So
right?
it's a cool idea. It would be very, very easy to get that because every question, every command question that requires the user to enter something at the R prompt requires the instructor to specify one expression that would answer the question correctly. It's not necessarily the only correct answer. There could be multiple ways to answer it correctly, but you have to specify one way of answering it correctly. So we could write a script in 5 minutes. It would grab that from every question and spit it out in a text file.
I think that'd be useful.
Yeah.
Spit it out as an RMarkdown file and then Slidify or something like
We're on GitHub, so if you want to do this, feel free to submit a pull request.
I think though, like, sorry.
No, please.
Like, it's sort of best coding practices is to write scripts because it's like you tend to write things cleaner as opposed
Sure.
to just like trying it.
So we're in the future. This is an idea that actually has some legs that we've fooled around with. Is we'll actually right now the user enters one line at a time. Right, it's an interactive form. The downside is, what if we say write a function that accepts one argument x and returns x squared? You could write that in one line, but you can imagine that more complex functions obviously require more than one line. So what do? Well, there's a function that allows you to edit the contents of a variable in R. And it'll actually give you a little pop-up window. And so what we can do is, if there's a function type question, it would bring up a little window with some text in it saying your function goes here, or possibly we could give them a little outline for the function, with some pre-filled stuff. They plug in their stuff, hit close, it returns the value. We capture that and then run a unit test on it. Feed it some input, see what the output is, make sure it matches. So these types of things would allow us to, like you're saying, write a script that does stuff. Yes. By the way, if you guys need to leave, go. I won't be offended. It's after 1:15.
I wonder if, just as you're capturing everything that goes on in the script, could you append, let's say, question, correct, incorrect, and output the set of everything that person typed and which ones were false and which ones were correct?
Yeah.
And I think that
For
would
an
help.
instructor, you mean?
I don't know necessarily for the instructor, but also for the student to have like the mark done,
Yeah.
the mark. Like,
Basically like a progress report.
exactly.
Yeah.
And so within that one, you could rerun the lines that you got correct and actually have a record of what doesn't work.
Yes. Yeah. So we used to have that in the first version of Swirl, but since we revamped it, we still haven't added that feature back. But that's in the works. It like as we speak. Yeah. Cool. This is the website. My girlfriend is a very talented graphic designer, so thanks to her, we look more important than we actually are. And some resources. If you are interested in Swirl to the extent that you would like to contribute to Swirl, come talk to me. There's many things that we need that we don't have the time to do. There's a ton of information on our website, whether you're interested in creating content or using it for your own learning purposes, or whether you want to actually contribute to the source code. There's something on the website for all those people. And it's just a lot of documentation in general. Yeah, that's it. All right. Any questions?
The math part, does it work if you're not using our studio?
No. So what do we do though? I mean, we could have the instructor. So the question was, can we our little math notation thing here? Like, what if they're not running RStudio? This is a Shiny app. So you could. The reason it's showing up in RStudio is because we specified a setting that says if the viewer pane is available, use it. If we don't specify that, it'll open a browser automatically. The reason I don't like that is because it pulls them away from the action. So what we're trying to avoid is jumping between screens, like changing tasks. We're trying to keep it all this continuous dialogue. And so the beautiful thing about this is it's right there. They're not distracted from what they're doing. It's all right there. In the future, we may, depending on where this goes, like we may build Swirl in such a way that actually it requires RStudio. We would be limiting ourselves a little bit, but I think RStudio brings to bear some pretty awesome stuff. That, basically my pitch to them is, you guys are like, you already provide the best IDE for doing data analysis. RStudio is the best place to do data analysis. Some people might argue that, but I think it's a fair comment. We want to make it the best place to learn data analysis as well. So I think that's a pretty compelling proposition. We think so.